And so we now start week 3. Um, Probably what you've noticed by now is there's a lot of stuff in these lectures. And some people said to me, gee, Dr. Joe, your lectures are kind of dry. And I know it's a data dump. But the point is that I kind of look at it as your 100 and 200 level classes are intended to be more engaging. But now you're at the point where basically you need information and you need to learn techniques. And so I'm giving you as much as I possibly can. Uh, However, after this, then we start getting into the meat of the course where we start talking about pricing and things like that, which you're probably a lot more interested in. Anyway, it starts with a question. How am I going to sell my product? How am I going to increase sales? Why do people buy my product? And these questions can all be answered by using conjoint analysis. And so the thing about these types of questions that we asked about a market, DOE is useful. DOE is proactive, though, that you're trying to basically find out. You have an idea of what works and what doesn't work. Conjoint is more post-active, that I already have a data set. Now I need to figure out what it means. And actually, you can find conjoint analysis, for example. It's on SurveyMonkey. But what it comes down to is that you start out with a profile, and those profile leads is defined by the attributes, which again are those variables you believe are driving sales. And also, how many levels of those attributes do I want to look at? And here's an example of a study done to look at intercity transportation choices. And so essentially the factors that are driving that are quality or information or the environment it's in. And so subsequently, based on those factors, there are factors that drive those factors. And so in this case, they've decided to use a tree. In terms of attributes, where they look at, and this is actually for cell phones, where they look at what do people value. So in terms of size and weight, they decide to use 3 levels. And in certain cases, it's just a simple yes or no question. Because let's face it, how much can you talk about voice recording? Either you have it or you don't have it. There's not much of variables in there. They're actually running things. And so here's how they constructed it by attributes and levels. So as you can see, here are the different attributes, and here are the different levels that the way they set up their survey. The thing is, levels can be attributes, and attributes can actually be profiles, or maybe attributes are just attributes. It depends a lot on the information required. Okay, so here's an example. I'm coming out with a new shampoo, and I wonder if I should brand it. How am I going to brand this new shampoo? How am I going to position this? And so we decide that the thing that people love about our shampoo, it needs to be shiny, bouncy, and voluminous. This is what is called orthogonal design. Does bouncy have anything to do with voluminous? Does voluminous have anything to do with shiny? No, none of these variables have anything to do with each other. Therefore, I don't have to worry about cross variances. And this is called orthogonal design. And it's very important if you want to create a nice, simple study. So I use a Likert scale of 1 means I don't care, and 5 it's critical to me. And so if I asked a question, your standard survey and saying, how much do I value shiny, how much do I value bouncy, and how much do I value voluminous, everybody will just say 5, 5, 5, 5. And it's kind of like, where does that get me? Okay, everything counts. And this is why you do combinations. You do combinations of features. And by the way people rank it, they will rank it according to a certain pattern. And the math will pull out which of those and how much they actually mean. The thing you have to be careful about is if you decide to do like orders or combinations, you can't make the list too long, because people start to lose track. Like if you decide to do an ordinal, I mean, somebody once sent me this survey, and well, to tell you the truth, I just want the free ice cream. But it was like horrible because they asked, here are 16 attributes. Well, they didn't call them attributes. And they ask you, rank it in order 1 to 16. And so you start ranking, and all of a sudden it's like, no, wait a minute. You're down around 9. I think I want to make this 4. And then everything has to shift, and oh my God, it's like horrible. The thing you also have to look at, again, is apply sanity to your testing. If you see really big standard deviations, like everybody's getting a 1 or everybody's getting a 9, then there's something wrong there. Then there's something systematic going wrong. And you have to think, well, wait a minute, is this data real or not? Or is it just a coincidence? One thing I joke about is, like on my student reviews, I have a tendency to, it's like 1s and 5s. And it's like, does that make a lot of sense? There'd be nobody in the middle. But think about it, who fills out a survey if it's just voluntary? Only the most passionate people. So the most passionate people who are going to fill out a survey are the people who are going to put 1s because they hate the professor and want to get even, or the people who really love the professor and want to help this professor out to show appreciation. They give them a 5. And so that was the rationale for that. And this is why you go conjoint. And that's it, again. Conjoint has many different forms. We've seen clustered conjoint, but there's also feature conjoint, and that's how I can put a whole bunch of features together in different combinations, and the math will pull out what's important. So what happens is I've got 3 variables, and I've got 8 combinations. But again, some of the combinations are meaningless, so you can drop them out of your testing. For example, what kind of rating do you think people are going to give for hair that's not bouncy, not voluminous, and not shiny? I mean, everybody's going to give it a 1. So it's sort of like, well, what's the point of even putting the question in there? All it does is skew the results and tells you absolutely nothing. And once you get your data, then what you can do is you can just use regression. And that'll be in the Excel lecture. So basically, we also threw in price. We want to know, will they pay a high price or will they pay a low price? And if you notice, I've taken out the extremes. There's not one with all highs or all lows. So we took the 6 in the middle. And so asking people what U is the rating people gave it. What you're looking at is for an F statistic or a T statistic. An F statistic level means, is the outcome random? If the outcome is random, then it doesn't mean anything. And the reason why is because you're trying to get a systematic answer to this. You want to know what people really think. But if it's not based on what people think, then that means you haven't really figured out anything. That there's no causality. A t-test just tells you, is there a relationship between this variable and this variable? Like in terms of U, is there any relationship between how they feel about the shampoo and voluminous, for example? And actually the big thing you see is a lot of these are just cousins. It's a cousin to DOE. And so by doing a regression, what I can figure out is, if you notice, my significance level is my F level is very, very low. So that means that this wasn't a random occurrence, that basically my data has meaning to it. And then if I look at the p-values, which is my t-test, what I find out is that my first 2 variables, bouncy and voluminous, basically, those are the 2 variables that have a relationship to the quality that people look at. And some of my data is inconclusive, and that happens. And that means you need to go out and get more data points. The thing about testing, it's about the length of the cycle and how many you can get in before you hit a limit. And so when you plan these kind of things, you have to think, okay, I have this much money to spend, and so how many times can I do it? The physical part of 310, the 16-week class. The students drove me crazy on their final projects, and the reason why is you have this team of 5 people, you have a whole semester, and they only send out one survey. And they said, well, this is what we learned from the survey. And then they would ask the question, why didn't you send out a second survey? Because they would say, well, these were the mistakes in the first survey, and this didn't work very well and stuff like that. That's why when you do these surveys, you don't want to send it to a lot of people. You want to do some sampling. You want to do some learning first before you send it out to the whole world. And of course, there are things like people catch typos and things like that, and you don't want to send it out like that. You just get embarrassed. In terms of other hints to help you test, the thing is, you have to understand what your return on effort is. And that's that if I can do a little more, can I get higher return? And the thing is, when I was at Michigan, one professor said, you can do enough and you can graduate. He said, but if you're willing to do a little more, you can do some great things. And so I just put in those couple of extra hours every day compared to other students, and subsequently I won awards. It's why my dissertation is in a book. Look for things that you can get for free, meaning if I could do things in parallel, or if I could do one thing that relates to many things, that's getting things for free. The thing is, mass testing can be resource and time intensive, so learn to adjust on the fly. Make your decision making a strength. And so here's an example of different kinds of testing. And the things I look for. If I test for distribution, I'm looking at the shape of the data. An example is sales by month. If I'm looking at A/B testing, and what A/B testing, and we'll get into that later in the course, is I look at 2 options. Like for example, should I do sampling by cell phone or should I do sampling by email? And so what I can do is I can figure out which technique works the best, or can I do a combination of those 2 different techniques? And we talked about t-test and f-test. The thing is, you can use these techniques over time, and that's called cohort testing. And cohort testing is you pick a set of tests and then you see how it changes over time. And that's more attuned to a digital class. And so, summarizing it up, this is a process you go through. What are my objectives? What are my attributes? How many levels? What methodology do I want to look at? And that's the thing. Choice versus preference. When we gave those 4 combinations, we are doing preference testing. Choice testing is when you use actual things that you are going to sell. And you know they're making an actual choice. Here we're just looking at preferences. Make sure my variables are orthogonal, collect my data, determine what my utilities are, meaning what are the outcomes of who's taking it, and then use and out of all those statistic models, what am I really interested in? What data do I want? And then do my calculations. And so the next lecture or video, we'll talk about Excel. And I know there are tons of Excel stuff online, but these are just a couple of little tricks and some very basic stuff that might help you out.